Hello, guys. It's Monday, and we resume our classes for this week as planned. I hope you're all fine. I don't want anyone to remain behind. Like I said, you can always ask questions when you need help. Okay, you can text me or you can post in the group. Since you don't want to post here on YouTube, you can use the group, but in the group I'll rarely respond because I've just dedicated a 1 hour to this program. So that's the reason why I usually emphasize on you guys coming here on YouTube to share to ask questions and share your thoughts. So we are going to resume our third class, which is lecture 4. Okay, I don't know if you guys can get me. Let me just confirm that. Let me just confirm if you guys can get me. Hope you're all fine. Okay, I believe my voice is audible enough for everyone to get me. So we shall continue from where we ended. Okay, today we'll talk about basic stuff. Okay, we're going to discuss basic stuff about um, C++. I want you to understand that it is the beginning that's going to help you understand better programming. If you don't pay attention at the beginning, then everything else is going to be foreign to you. Okay, you need to understand the basics. The same things that we're doing at the beginning, the data types, okay, functions, conditionals, all those things that we're going to be doing at the beginning, you really need to get them. Once you're left out from there, it's going to be a challenge for you to understand the complex part of programming. Okay, and the other thing that I can tell you is programming is a journey. Don't rush into difficult stuff already because of the few things that you've learned. Okay, just use the things that we have covered. If you're covering content on your own and you have moved forward, that's a good thing. Okay, it's a good thing, and practice is what's going to make you better. So you need to be patient. If you're following me, you need to be patient because I'm taking it slow. I want everyone to understand so that we shouldn't leave anyone behind. It wouldn't be fair. Okay, so these basic data types here on the screen, we discussed these last week. Okay, um the data types have got different sizes. Okay, they've got different sizes and uses. Okay, for instance, the boolean data type has got a size of 1 byte. Okay, a size of 1 byte. It stores a true or false values, 1 or 0. Okay, the car or char, I don't know how you pronounce that one, also has a 1 byte. So a byte is um one 8 ones. Okay, 8 ones, 8 bits make a byte. So if we say 4 bytes, meaning that you're saying 8 times 4, which is 32. Okay, 32 bits, that's 4 bytes. Okay, so int, there are two types of int. There's a short int and a long int. Short int is 2 bytes. So if you are going to be writing small numbers 1, 2, 3, you know that you're going to be dealing with small numbers, better you use a short int. Just write int. Okay, so in short, int stores whole numbers without decimals. Okay, then we have a float. A float has got 4 bytes. It stores fractional numbers containing 1 or more decimals. Okay, sufficient for storing what, 6 to 7 decimal digits. Okay, a double, on the other hand, has got 8 bytes, stores fractional numbers as well, contains 1 or more decimals. Okay, sufficient for storing up to 15 decimal digits. Okay, the numeric types. Okay, numeric types store numbers. When we talk about int, is a numeric type which stores whole numbers. Okay, like 35 or 1000. A float or double stores decimal numbers or floating point numbers. Okay, for example, 9.99 or 1.314515. Okay, these are the examples below. Int can store 1000. You create a variable and give it the value 1000. Int is going to store a number without a point. If you say 1000 dot point 0 is akana, unless you use you remove the point. That's how integers work. Float and double is going to work for decimals. Okay, now what is the difference between a float and a double? Because they both store what? We've been told they both store fractional numbers. Okay, they both store fractional numbers, but what is the difference? If you pay attention here, what can I use to draw? Sorry, let me just look for something I can use to draw. Okay, this is a bright color. If you pay attention here and here, okay, float has got 4 bytes, double has got 8 bytes. Okay, why? These numbers or types, a float and a double, are going to differ in terms of precision. Okay, precision, like we saw earlier, say a float is going to store 6 to 7 uh, bytes. Okay, sorry, not bytes, 6 to 7 number decimal places. Okay, decimal places, but double 15 decimal places. Okay, 15 decimal places, meaning that if you want to have more precision, okay, more precision, you're going to use a double. But if precision isn't really much of a matter, or maybe you don't want that precision, then you can use a float. Okay, a float is going to suffice for 6 to 7 decimal places. But if you want more precision, more accuracy, because uh, you're going to get a decimal number that has got a lot of decimal places. Okay, then scientific numbers. Floating point numbers can also be scientific numbers with an E to indicate the power of 10. Okay, so in C++, you can use the exponent to indicate a power of 10. Okay, like this example here, float f1 is equal to 35 power 10 power 3. Okay, double D1 is equal to 12. This capital E and this, they are just one and the same thing. The compiler is going to consider them as the same thing, okay? Moving on to Boolean types, okay? A Boolean data type is declared with the bool keyword and can only take the values true or what? Or false, okay? True or false. True for 1 and false for 0. Those are the values that these two, the Boolean type takes, okay? For example, you want to declare a variable of Boolean type, you're going to say a bool, then your variable name. For example, here we wrote bool and is coding fun. Okay, is coding fun. That's how you declare Boolean data types. Okay, that's how you declare Boolean data types. So these Boolean data types are usually or mostly used in conditional statements. You will learn about conditional statements later on in the coming chapters, okay? Like I said, you need to be patient because if you rush, you won't understand. You'll get confused. So if you have questions, you can write them down. Then when we discuss conditional statements, if you don't understand, then you can ask me. But for now, be patient because we're going to cover these things, okay? We're going to cover everything that you have to know. Okay, so let's continue. A character types. The char data type is used to store a single character. The character must be surrounded by a single quote. Okay. For example, like we have written in this example here. I don't know if you can see that, but this is the example I'm talking about. Okay. Char my grade is equal to B. Then you should surround the B with single quotes. Okay. When you want to print out that character, you use the variable my grade and the grade is going to be printed to the screen, say B. Okay. Then also going to talk about the string types. Okay. The string type is used to store a sequence of characters. You don't want to store one character always. There are times when you want to store a sequence of characters, a letter, a message, okay? You want to use a string type, okay? This is not a built-in type, but it behaves like one in its most basic usage. String values must be surrounded by double quotes. So the string, even though they keep characters, you don't surround them with one or single quotes, but rather use double quotes to indicate it's a string. So if you were to write one letter and then you surround it with double quotes, the compiler is going to consider that as a string, okay? And it is going to preserve the bytes that we saw earlier to say the string that I'm about to store is going to need this much amount of memory, meaning you're wasting memory like that, okay? So we move forward. If we didn't put the standard library, for instance, on top of our code, if we don't put the standard library, what we do is to use the strings, you must include an additional header file in the source code string library. Okay, so earlier we decided to use include IO string. So even for string, if you want to use it without including your standard library, then you need to put this header hash include string. Okay, then you'll be able to use the string type here in your code. Okay, so we are going to move forward. We're going to move forward. We have C++ operators. So C++ operators are used to perform operations. Okay, in short, in programming, any language, when we talk about operators, those operators are going to be used to perform operations on variables and values. Okay, variables and values. Variables store values. That's the difference. A value cannot store a variable, but a variable is a container. Okay, a variable is a container, it can store those values. So in the example below, we use the addition operator, this plus sign here, okay, to add together two values. We're adding 150. So int x is equal to 100 plus 50. Okay, so we use operators to perform operations on variables. So since we're right now we've talked about values, we're adding 100 and 150. This operator, the plus sign, can also be used to add variables. Okay, although the addition operator is often used to add together two values, like in the example above, it can also be used to add together a variable and a value, or a variable and another variable. Okay, the examples are provided here. We added 100 plus 50, we added sum 1 plus 50. So for instance, if this was a code or a program, we'd say when we add 150, we're going to have 150, which is going to be put in this variable. Okay, it's going to be stored in sum 1, and then sum 2, we're going to say sum 1 plus 250. It's like you're getting the 150 which is stored in sum 1 and add it to 250, thus you're getting 400. Okay, then when you say sum 3 is go to sum 1, sum 2 plus sum 2, meaning you're adding 400 plus 400 to give you 800. Okay, so the different types of C++ operators are provided below. We've got arithmetic operators, the normal operators that we know for mathematical operators like addition, subtraction, multiplication, division. Okay, these are referred to as arithmetic operators. Then assignment operators, these are used to assign values to variables. Okay, they're used to assign values to variables. Comparison operators, these are used to compare two values, two variables. Okay, two entities can be compared using the comparison operator. Logic operators, these are used to perform logic in your code. You get to learn about these as we move forward. So let's talk about the arithmetic operators. Okay, these are used to perform common mathematical operations: addition, subtraction, multiplication, division, modulus, increment, and decrement. These are the most common ones that you use almost in every code that you write. Okay, if it deals with mathematical operations. So add two values together. You can add even more than two, but for the example, we're just showing you. Okay, it's adding two variables x and y, it's subtracting x and y. Then multiplication, you don't use the x in your code, rather you use this star asterisk, okay, the asterisk. So you say x asterisk y, so ni x times y here. Then the forward slash, when you put it in between two variables or two numbers, that's division. Then this percentage sign is called the modulus. This one gives you the remainder when you divide two numbers, and if those numbers leave a remainder, the remainder is what's going to be your result. Okay, you won't get the dividend, but rather you get the remainder of the was this sorry the quotient. You won't get the quotient, but you will get the remainder. Okay, increment, this one adds 1 to a variable. Okay, this one adds 1 to a variable. So when you put the plus plus in front of the variable, the 1 is going to be added. For instance, if we were to say plus plus x, then C out x, we're going to add 1 to x, and then that's when it will give us the addition. But if we put the plus plus in front of the x, we're going to get the value of x before we get the addition. Okay, same applies to the decrement operator. This one is going to decrement the value of x by 1. If we put it in front, the opposite is going to happen. Okay, it's not the opposite, but rather I'm trying to say we're going to get, if for example, it says C out x, if we put the decrement operator in front of x, we're going to get the value of x before it subtracts. The next operation is when it's going to subtract. Okay, then assignment operators are used to assign values to variables, like I explained earlier. Okay, in the example below, we use the assignment operator. The equal sign, the ordinary equal sign in programming is called the assignment operator. If you want to write equal, depending on the programming languages that you're doing, but for C++, if you want to write equal, you write it two equal signs, then you read that one as equal. But for this one is an assignment operator. Okay, so to assign the value 10 to a variable x, we say x is equal to 10, meaning that we are putting 10 into x. X is going to store 10. The addition assignment operator plus equal, that's what it is called, addition assignment operator, adds a value to a variable. For example, when we say x is equal to 10, then we can say x plus equal 5. What we're doing here, we are getting the value of x and adding 5 to that value, and then giving the total, assigning the total to x. I don't know if that is clear, but the following list is going to help you understand what I'm trying to explain here. Okay, a list of all assignment operators. So we've already talked about the equal sign here. This one is an assignment operator. It's not equal. I'm just using equal for the sake of explaining, but it is not equal. This one is an assignment operator in programming. Okay. This one, addition assignment, subtraction assignment, multiplication assignment, division assignment, modulus assignment. What they do is, when I write x plus equal 3, what I mean is I'm getting x, assigning it the value of x plus 3. Okay, that's what this means. Here, I'm dividing x over 3. The remainder that I get, I give it to x. I assign it to x. Okay, that's what is happening here. Here, for instance, x minus equal 3, what we're doing is we are subtracting the value in x. We are subtracting 3 from the value of x. Then the value that we're going to find, the result that we're going to find, we assign it to the variable x. Okay, that's what these assignment operators do. Comparison operators, these comparison operators are used to compare two values of variables. Okay, this is important in programming because it helps us to find answers and make decisions. Okay, when you start doing logic, you get to understand how these comparison operators help us make decisions. You know, for example, you can say uh, is 2 greater than 10? You compare. Okay, then from there, if 2 is greater than 10, you can make a decision. Okay, I'm going to do this, but of course that is false. 2 is not greater than 10. So maybe the 2, if 2 is greater than x, so x is a variable, it's going to depend on a certain output somewhere else. So if x is greater or equal to shan, is that's what's going to determine what the code is going to execute. Okay, that's what comparison operators help us with. Okay, they help us compare. So we've got greater than operators, less than, less or equal to. Okay, now these comparison operators are here. This is the equal to. Okay, told you that this is how you write equal to in programming. Okay, defining mathematical terms now. Equal in programming is equal to. Exclamation mark and equal to in programming is equal to not equal. Okay, x is not equal to y. That's what this statement here means. Okay, x is not equal to y. That's what this statement means. Okay, we move forward. Greater than, x is greater than y. Okay, less than, x is less than y. Okay, greater or equal to, this one is x greater or equal to y or less or equal to. Okay, these are the comparison operators that you meet when you are doing your programming. Okay, then